All right, problem number 10 wants to determine whether the function is linear or nonlinear. So similar to the one we've previously answered, we would count the difference in the x values. So we're going to see that this is counting by 1. We start at 1, goes up by 1 to 2, goes up by 1 to 3, 4, and 5. So this is counting by 1. We see a constant rate of change. But if you look at the y column, okay, the y values, we start out with negative 28, and then negative 4, and then 3, negative 1, and 10. All right, so the difference between here, negative 28 going to negative 4, so you always take the second term, negative 4, subtract, so minus a negative 28, which would be a plus a positive, so you get a difference of 24. Why did I write 42? 24. 24. So this increased by 24. But when you look at the difference between here, it only increased by 7. So if you do 3 minus a negative 4 plus a positive, so you get 7. The fact that these are different, this is not a constant rate of change, means that we do not have a linear function. So this is not linear, and because it's not linear, we can't find the slope. Okay, so number 11, we want to determine whether the function is a polynomial. We're going to state its degree, and tell if it is not a polynomial, tell why. We're going to write it in standard form, and we're going to identify the leading term. Okay, so this polynomial, we would have to multiply it out and put it in simplest form so we can answer all of those parts. So we can determine that it is a polynomial. It is a polynomial. We don't have any fractional exponents, negative exponents, or variables in the denominator. So yes, it is a polynomial. The degree, you have to count how many variables you have. So we have this x squared counts as 2 x's, okay? And then over here we have another x, but it is raised to the second power when you FOIL it. So we have 2 x's here and 2 more here. Altogether we have 4. So this is a 4th degree. All right, so now that we've confirmed it's a polynomial, found its degree, we now want to write it in standard form, identify the leading term and the constant term. All right, so I'm going to write this down and we're going to just multiply it out. Okay, so this is number 11. So we have 3, and then we have x minus 1 in parentheses squared, and then we have x squared plus 2. All right, so what we're going to do, we're going to FOIL this first. So I'm going to do the shortcut. You square the first term, so you get x squared. You multiply these two terms together. That will give you negative x, but you double it because of 2. So minus 2x. And then you square the last term. So 1 squared will give you a positive 1. All right, we're going to multiply that or FOIL that out with the x squared plus 2. So I'm going to multiply all of these times x squared and then all of these times 2, leaving the 3 on the outside. So x squared and x squared will give us x to the 4th, and then 2x, negative 2x times x squared will give us a negative 2x cubed, and then 1 times x squared will give us a positive x squared. All right, now we're going to multiply all these times 2, so that will give us, I'm going to line it up with this like term, 2x, I can just write it behind it, be plus 2x squared, and then 2x times 2, that will be minus 4x, and then be a positive 2. So this is what we get when we simplify it. We will have 3 times the quantity x to the 4th minus 2x to the 3rd. Add these like terms together. That will give us plus 3x squared minus 4x plus 2. And then lastly, we're going to distribute the 3 through. So this will give us 3x to the 4th minus 6x cubed plus 9x squared minus 12x and then plus 6. So our leading term and then our constant term we can see now. So we have in standard form 3x to the 4th minus 6x to the 3rd plus 9x squared minus 12x plus 6. The leading term, 3x to the 4th, and then constant term is 6.